Hey guys, welcome back to my channel. Today let's talk about confidence interval. Okay, confidence interval. Let me just give you the most intuitive understanding of confidence interval. What does it mean by saying I'm 95% confident? Okay, so how do I understand confidence interval? Okay, without further ado, let's get into it. Okay, let's talk about confidence interval. Okay, confidence interval. Let me write it here. Confidence interval is for a population parameter. Just take a population mean as an example. Okay, so let's suppose you have this many observations in the population, and the thing you're interested in is test score. So for each individual, you have a test score. And because this is the population data, right? Population is unique. So based on this n observations, you can calculate a population mean mu, which is sum x over n. And the value of this is unique because the population data is unique, right? And then that's just because most of the time, because in practice we don't have population data, so but we want to estimate, we want to know the population mean mu, right? So what we can do is we just rely on a sample data. So out of this population, I take a sample contains this many observations. So this is my sample. This is what my sample look like. X1, X2, same variable test score, and then based on this data, I can compute a sample mean, right? So sample mean, let's suppose sample mean is 85, my old friend, 85 sample mean. So this 85 is the sample statistic, we know that. So this is the sample statistic, and this is a population parameter. So population parameter mu is unique, the value mu is unique, but the sample mean is subject to change. So different sample, we might have a different sample mean. Let's suppose in practice we only have one sample. So now this 85, we call this point estimate of the population mean. So this is a point estimate of the population mean. So that means they give a single value that can be used to estimate the population mean, and this single value is sample mean, right? Just my best estimate, my best guess of population mean is the sample mean 85. But the confidence interval is, you can be more informative, right? You can say, okay, I'm 95% confident that the population mean mu is within a certain range. So now this range is based on this, right? This is your data, so just based on the sample statistic, you can construct a confidence interval. You can, based on the sample data, the sample statistic, you can construct a interval with a confidence statement. So you can say, you want to say, I am 95%, right? I am 95% confident that the population mean mu is within a certain range. Or I'm 99% confident that the population mean is within a certain range. Or I'm 90% confident that the population mean is within a certain range. So the different range, maybe this EF, different range depends on not only the point estimate of population mean, the sample mean x bar, but also depends on the confidence level. So this probability, right, this 95%, 99%, 90% is called a confidence level. It's called a confidence level. We'll just use 95% as an example, how to construct a 95% confidence interval. So in order to construct a confidence interval, you need to know the distribution of this variable x bar. So now you see we need a central limit theorem. So let's suppose we have this. Suppose n is large enough, or suppose population is normal. So suppose we know that x bar follows normal distribution like this. So that means any point, any values of x bar, right? Any point along this x-axis is the values of x bar, right? Any point along the x-axis is the value of x bar. So any point along the x-axis is a point estimate of population mean mu, right? Let's suppose we know x bar follows normal distribution, and then we know central limit theorem. Okay, the very important central limit theorem, and then the mean of x bar, we call it expected value of x bar, or equals mu sub x bar. We know that. Check out my central limit theorem video. So this equals population mean mu. So this is always equal to population mean mu. These two things are equal. But we don't know this, right? We estimate this using sample mean. Let's suppose sample mean is somewhere here, right? Let's suppose sample mean somewhere here. But the thing is, we don't know where to point out the sample mean 85, right? So, and this is the only thing we know. So right now we just center around 85. So let's suppose 85 actually here, let's just center around 85. This is the X bar, we center around 85, and we know X bar follows normal distribution. We just assume that this normal distribution, the average is 85, because this is our best estimate or point estimate. And so these are two exactly same distribution, and 85. Center around 85, we construct a 95% confidence interval. So now 95% in the middle, so that means this is the 95%. So 95% in the middle. So this is 95%. Central limit theorem, right? So X bar follows normal distribution. If in the middle 95% is symmetrical, we know that this should be 1.96 standard deviations above the mean, 1.96 standard deviations below the mean. Right, so now this point is 85 plus 1.96 times standard deviation of X bar, which is standard error. And this point should be 85 minus 1.96 standard deviations below the mean, standard error of X bar. So central limit theorem, check out my video about central limit theorem. You know that. Central limit theorem, X bar follows normal distribution when n is large enough, and mean of X bar equals population mean, and the standard error of X bar equals population standard deviation divided by square root of n. Okay, when n is large enough, equals s over square root of n. Okay, so that's, if you know number, you know the sample size, you always know n, you always know the sample statistics, so you always know the standard error, right? So now you can say 95% of the time, or I'm 95% confident that the population mean is within this range. Or let me write it this way. I'm 95% sure. I am 95% confident that the population mean is within this range. I just write 85 plus minus 1.96 times standard error of X bar, and this is actually we just or we can say the point estimate of population mean. So actually, this is the way we state this, the statement. Right? This is the way we put everything into a sentence. I'm at 95% confident that the population mean is within this range. It's actually, or i.e., I am 95% confident that X bar is within this range. X bar, which is point estimate of the population mean. So I better write here, right? X bar is point estimate of the population mean. Okay, so now the difficult part or the challenging part, if you still is the challenging part or difficult part, is to understand this. What does it mean by saying 95% confident? What do you mean 95% confident, or 99% confident, or 99% or 90% confident? What that mean? Okay, so to understand this part, okay, 95% confident, we just need to understand this this graph. So we have this X bar follows normal distribution, right? If this is the population mean, this is a true mean, but based on the sample mean, maybe 85 somewhere here, you construct a 95% confidence interval, maybe like this, right? So this is 85 plus minus 1.96 times standard error. Right? You take a different sample, you might have the sample mean somewhere here. Maybe it's X bar, your sample mean, and based on this sample mean, you construct 95% confidence interval, right? So that's X bar plus minus 1.96 times standard error. And maybe you take a different sample, you have sample mean somewhere here. And then based on this sample mean, you can construct 95% confidence interval. And maybe this sample, you have this large sample mean. Right, sample mean is over here, and then based on this, you can construct 95% confidence interval. You can, if you have this much sample mean, this is a sample, a different sample, you might have different value sample mean, right? So then you have this 95% confidence interval. The sample mean is over here, you have this 95% confidence interval. It's like, it depends totally. the confidence interval, a 95% confidence interval is totally dependent on the sample mean, right? The confidence interval totally depends on which sample you're using and what sample means you can get. So if this is my sample mean here, and this is my confidence interval, you can say, okay, 95% population mean is in this range, but it turned out that population mean is really in this range, right? That means you make a right estimate, right? So here, if the sample mean is here, 95% confidence interval, maybe some population mean is still right within this range. But what about this? If this is your sample, and if this is your sample mean, right, based on the sample data, this is 95% confidence interval, but it turned out that population mean falls outside of this interval. But you can still say I am 95% confident that the population mean mu is within this range. Nothing wrong with this statement. You can still say that. Why? Pause this video, think about it. Why? We can still say I'm 95% confident that population mean within this range, even if it turned out that the population mean falls outside this range. Why? Because you're not 100% confident. You allow yourself to make mistake 5% of the time. Okay, like this. If this is your sample, compute the sample mean, and based on the sample mean, you construct 95% confidence interval like this, you can still say I'm 95% confident because this is a 95% confidence interval. But when it turned out the population mean fall outside this range, doesn't matter because I am not 100% confident. I allowed myself to make mistake 5% of the time. So yeah, this could happen, but only 5% of the time. Okay, this could happen, but only happens 5% of the time. So that's why we call it 95%. 95%, to understand this term, 95% means 95% of the similarly constructed intervals will contain the true population mean. Or the true population mean mu falls into 95% of these intervals. Now suppose totally you have 1,000 intervals constructed and 95%, that means 950 intervals will contain the true population mean. So 95% confident means 95%, I mean right here, that means 95% of the similarly constructed intervals will contain the true population mean mu. That's what we mean by saying 95% confident, and this 95% is called a confidence level. Okay, if you're using 99% confidence level, and then that means 99% of similarly constructed intervals will contain the true population mean. So this could happen, but only 1% of the time. Okay, so yeah, this is how we construct confidence interval, right? Based on a sample mean, right? This is a confidence interval for population mean when n is large, or sigma is known. Okay, but when n is small sample and sigma is unknown, we should use t-statistic, right? Check out my previous video about the t-distribution t-statistic. Okay, so confidence interval, confidence level. Hope you find this helpful. Hey guys, hope you find today's video helpful. Any questions, comments, please comment down below, let me know, or send me messages. Your questions are very inspiring, so actually a lot of my video ideas come from your comments. Please do it. Comment down below. I read actually every one of your comments. The next video is going to be about the second episode of hypothesis testing, so stay tuned. Okay. Yeah, thank you so much for watching, and I'll see you next time. Bye.